The majority of cases of atrial fibrillation, however, are not focal, but represent multiple micro-reentry circuits within left atrial myocardium that is diseased because of dilation and fibrosis. And we know that to stop atrial fibrillation, it is necessary to compartment. I've just shown you the macro-reentry circuit that is responsible for atrial flutter. We know that that is the major circuit in the commonest type of atrial flutter. But now we are particularly interested in atrial fibrillation. We know much less about atrial fibrillation, but we're learning more all the time. And I want to show you some potential aspects of atrial fibrillation using this large adult heart, which has been dissected by Dr. Damien Sanchez-Quintana of Badajoz, by removing all the epicardial tissues so you can see the orientation of the fibers in the ventricles and also particularly in the atrial chambers. And I want to discuss with you how the orientation of these fibers is potentially of significance in the genesis and the continuation of atrial fibrillation. If we look first at the left atrium, and I turn it so that you can see the dome of the atrium. You see here is the coronary sinus with its own muscular walls running within the atrioventricular groove. Here is the inferior cable vein, and of course now we're looking at the heart from behind. You can very beautifully see how the orientation of the fibers themselves change within the structure of the left atrium. There are circumferential fibers running here around the vestibule. And then there are these longitudinal fibers which run over the dome of the atrium. This specimen shows us very beautifully, if we look at it from above, the large extent of the dome that separates the mouths of the left from the mouths of the right pulmonary veins. And if we concentrate for just a moment on the union, the junction between the pulmonary veins and the atrial chamber, we see here at the union of the left upper pulmonary vein, there are discrete circumferential fibers which run along the pulmonary vein and extend towards the pulmonary parenchyma. Now my colleague Yen Ho has measured the extent of these fibers, and they are greatest here around the left upper pulmonary vein. And it cannot be coincidental that here around the left upper pulmonary vein we find the commonest focus for the focal form of atrial fibrillation. And it could well be that these circumferential myocardial fibers have something to do with the focal form of atrial fibrillation. The majority of cases of atrial fibrillation, however, are not focal, but represent multiple micro-reentry circuits within left atrial myocardium that is diseased because of dilation and fibrosis. And we know that to stop atrial fibrillation, it is necessary to compartment the atrial myocardium, both in the left side and in the right side. And to do that, we need to understand very well where the lines can be made so as to be able to divide this myocardium into different parts.